Put up. Yeah. So, good morning, everyone. I just wanted to share a story for the next few minutes. It's a personal story. I'm an AI nerd by training. When I was a kid, I wanted to be an astronaut, so I went to MIT. Turns out I can't fly with my glasses. So I fell in love with AI and robotics in the AI lab back in the era of Marvin Minsky. And back then, we started doing AI, and my parents were like, what's that? And I started to study that, and I graduated, and I couldn't find a job. Because back then, when we did AI, it just didn't work. It was fun, but it didn't work. And Marvin Minsky at the time wrote this book called Perceptrons. Perceptrons was about this community that was trying to recreate the human brain using artificial neurons. And he largely, I wouldn't say ridiculed it, but sort of put it in its place saying, this is never going to work. And we tried that, and it never converged. And then I was on my merry way, having some jobs. I was in IBM Research. I was in the CEO's office there. I did some startups. Then I was in the CEO office at Price Waterhouse. And then this happened. This is me. This is my rendering of myself on the left. As you can see, I'm an artist. And then what happened is I was on Facebook, and a fraternity brother of mine, Phil Nelson, was at Google Research, and he sent me this posting of what he called the $500 million demo. And his whole posting said, WTF. And what this was fascinating. This was built by neural networks. There's no code here. It's 4 pages of math. And the way this thing works, it's 150 by 250. It's an old Atari game. And they chop out an 84 by 84 section of this. And what they do then is they attach artificial neurons to each pixel. So each pixel has a neuron attached to it. And the output of this 4-layer network is a joystick. So you have pixels coming in and a joystick going out, and you can do up, down, left, right, diagonal, and fire. And you hook this thing up in what's called reinforcement learning, and you train it by just having it play its own game like a teenager. And you'll see in the breakouts later, this thing, what really shocked even the researchers, because they were good at math and good at AI. But if you look at what's happening here, see how it's digging a tunnel on the left? That's a whole strategy it figured out. And this same algorithm, the same math, it played 250 games. It played 50 better than any human being ever had played before. The exact same code. And we have 100 billion of these things, give or take. I don't know if anybody's actually counted them, but 100 billion of these neurons in your head, and they fired about 200 times a second. This is 4 layers. This is not even on a pin head in terms of the number of neurons, and it's playing 50 video games. Now, my reaction was I started following my friends, and they ended up coming to Google, because Google wanted to go after this and said, this is such a huge breakthrough, we should really do this for mankind. But look what Google did. So Jeff Dean was at Google when we purchased this company for about $500 million, and he said, if this is true, if we are actually, as a human race, finally cracking perception, much like we cracked flight or superhuman strength with hydraulics. If we've cracked perception, and if concepts are just points in space, what about human beings talking to each other? That's a lot of data. Could we actually encode speech and have speech come back out in a different language in real time? So Jeff and a few friends, and it was actually Andrew Ng and others, that had this team. They called themselves Google Brain. And they did a back of the envelope in 2014 and said, and this sort of is their architecture for going from one language to another. And this happened. They looked at this and they had a conversation. I wasn't there, but I could imagine it, with Larry and Sergey, and said, hey, if we do this, if we take this DeepMind breakthrough and we do this for neural translation, if everyone has an Android phone, take your phone out, would actually speak in it for just 3 minutes and try to talk to somebody else, usually we speak a lot more than 3 minutes a day, we would smoke every single server Google owned. That's not good. And so they decided to rethink from first principles, how do you actually put this into production? This is 2014. So the first thing they did is they went to where the processing happens. Back then, we all used GPUs. A GPU is really neat because when it's shading pixels, the math to shade a pixel on your PlayStation is the same math to fire a neuron. It's called a convolution. Who knew? Now, they were using a GPU, but there's a lot of stuff in a GPU, like from NVIDIA and elsewhere, that you don't really need for this. So they rebuilt the entire processor and said, this is cool, and this is now to fire neurons at rapid pace at a frame rate. But that's not enough. Since this is artificial, these sort of brains are not limited by our hips like we are as human beings, because you can't get such a big head down the birth canal. So they decided to go big and said, well, let's make neurons switch about 200 times a second. How about 1,000 times faster? So now you build a switch, and they built their own network interface cards. They have their own fiber. And they built this entire switch to get to a petabyte per second. Sounds pretty cool. So they built that huge switch. And this is a custom network card. The next thing they said, well, now we got the chips. Now we have the switch. So they started to build data campuses. I was instructed by a fellow person in my office who said, Scott, we don't have data centers at Google. We have he's spitting right here. We have data campuses. These are campuses built for the inhabitants, and we're visitors. So this is the one part where humans can walk, and you walk down the cold aisle, but you have to wear shorts and you sweat a lot. I was just at one in Atlanta. So you walk down the cold aisle, so it's proprietary how hot it is, and these are all the servers lined up, and basically an entire bank of just computing units and storage units. And that's the hot aisle that you can actually service. And then this thing has to breathe. Now, our brain is a few watts. This is a lot more than a few watts. And it breathes out the back. So you suck in the cold air and you breathe out the back, and this is very, very hot, sort of face-melting heat. And then as it's breathing out the back, you need to cool it like we do it with blood. This is the blood of the data center. 3 different pipes, 3 different colors. One goes to the back, and it carries the cold water from the servers and gets heated up by the servers and comes back. That does a heat exchanger with the other coolers in a second color. And then a third color says, you have to exhale. You got to exhale. So you exhale to the environment through these coolers. That is a Google data center. That was $30 billion. I looked at it. I was looking for my next job. Google said, let's go spend $10 billion a year to go build this. And when they built this, this is the piece I love. They had some of the world's experts in high-energy physics, thermodynamics, data center cooling. All these people together had worked for years to optimize the data center and this track called PUE. How much power efficient are we trying to get to a zero carbon footprint? So they said, well, why don't we turn the AI on itself? So now we use that math, that feedback loop that was used for playing that game, which is a reinforcement learning, is now used for the data center. So that the chips are actually using math to control itself and moving workloads back and forth. And what you're seeing here is how much power on the left. You turn on the machine learning knob, it drops by 40%. 40%. Think of all those world experts we had grinding on this for a decade. The math plays for a few months, 40% better. Now, Jeff goes, okay, can we turn this on? And they turned it on, and now